one of the very first members of our core, so we have all benefited from Martin's work for many, many years. And being Swiss, Martin obviously has a thing with precision. And we have all also benefited from that for many years. And now that I'm here, I can't resist the temptation to mention that next year's useR will actually take place in Europe, not surprising, but in Aalborg, which is the fourth largest city in Denmark. And there's a website up there, and I hope to see very, very many of you in a year's time. Without further ado, Martin, please.
Okay, thank you, Søren. Yes, thank you very much, organizers, for inviting me to this talk. I got a green name tag, which means I'm from industry, and I assume that's because I was marked R core, and it seems that some people believe R is produced by a company, but I think most of you know that this is not true, and practically everybody in the R core team is actually in academia, with a few exceptions of people in research labs that behave as if they were in academia. So, this is a quick overview of what I'm going to do. Probably there are too many things I couldn't resist of showing R code and stuff like that, and at the same time trying to talk about the topic of good practices in R programming. So I have only one slide about history. John Chambers had many more, but he has much more to tell anyway about that. 10 years ago was May was the first useR conference at all in Vienna. There were 8 keynote talks, all by R core members, about exciting new features in the R language at the time, such as namespaces, were very new by then. R version 1.9.1 was a month later, was due, and had some of these new features. Anyway, I then was one of the R core members who gave one of those talks, and the title was actually not much different than this title. I was also about hints and programming using R and good stuff. And so this slide is actually not very different. So the second section of this presentation is a little bit a rehash of what we did, what I did 10 years ago, and looking at have things changed much in the sense of R programming, good R programming, and then I look at other things. So here I'm talking about what the talk is not about. It's not comprehensive. It's not something like a book, famous one, the Green Book by John Chambers, Programming with Data, or other books, Venables Ripley, Uwe Ligges, or Norm Matlav's, of which I particularly like the title, The Art of R Programming, as one of the newer ones. The talk is not for complete newbies, but also not really for experts. I'm trying to cater to all of you, and if I'm succeeding, all of you will hear something exciting, or at least funny, something you didn't know, hopefully. It's not about C++ and other language programming, and also it's not always entirely serious. I'm trying to have you laugh occasionally. It is about all language programming. It is my own view and hence bias. It's hopefully helping users to improve their R skills, and somewhat entertaining, hopefully, as well. Good practices in R programming, that's again the title that the talk has. It's good practices, it's not best practices. I don't believe that you can give general rule for best practices, even though that's a very common title in the industry, as I know. Programming using R, that's the title of our conference. It has been for 10 years now, as I said. And it's practice what I've learned over the years with examples. I've been in academia, not being in a big company like some of you are, where you really have different problems to solve. Anyway, what is programming in the way I'm talking about? And coming back to that book tab, is programming like driving a car a skill you learn and then know to do? So you go to university or to some programming courses, you become a certified programmer, and things like that? Or is it a scientific process to be undertaken with care? I'm from academia, so I would like it to be like something like that. Or is it a creative art? Well, I claim it's all of them, but not the least an art. That's Norm Matloff's book title, which I like. Your art programs, and that's the goal of this presentation, should become something like works of art. In a small scale, in a non-professional artist's way, but still. And in spite of that, I still talk about rules for good practices in programming, and we'll talk about guidelines, ones that probably were already mentioned by me 10 years ago. Okay, so this is the second part. 7 guidelines for good practices in R programming. And rule 1, work with source files. Nowadays, this is more common than it used to be. Our source files are typically called R scripts. But there is more to it, as most of you nowadays know. For many of us, it's obvious, but I still see that most R users probably are kind of working more in the console, at least my students do, because they typically have small-scale problems to solve, rather than with scripts. Not just my students, I also see PhD students and researchers do that. And I think that's a big success compared to 10 years ago. We have seen this paradigm shift more or less. 10 years ago, people still thought many of the talks in useR conferences were about the theme, how can we add a GUI to R? R is bad because it doesn't have a GUI. I think many people, particularly in this room, know that this is not, I mean, you can have interactive interfaces, but it's not for programming, it's for interactive exploring stuff. Nice things that we've seen in the presentations. So we don't edit objects and fix them, but you modify, re-evaluate their source code. And you can do this in different ways. There was an old saying in the ESS manual, the source code is real, the objects are realizations of the source code. Of course, typically in object-oriented programming, you think of objects are something real, and that's not wrong. But in this sense, the objects are a consequence of the source code. Okay, and to do that, and that's also a paradigm shift that I usually don't have to preach this in this audience anymore. You have to use a smart editor or an IDE, an interactive development environment, that is syntax aware, that does highlighting, use colors. It's able to evaluate R code line by line, section-wise, whole function-wise, whole files. You have command completions on R objects, functions on help topics, and so on and so on. And here I mentioned a few of these. The historically most important one probably has been Emacs with ESS, which stands for Emacs Speak Statistics, which really came about long before R came about. It was used for S, even at Bell Labs. Our studio nowadays is definitely the most used one, and there's also R plus Eclipse, which is kind of this computer science IDE, and stuff. There are more. So some of them that are not available on all platforms, which I've emphasized here. Anyway, to work with source files comfortably, you have to use one of these nice environments. And I think most or all of us in here will do that. Now, good source code, or if you want to use, have to use, or are convinced you should use files with sources, then you better get a good organization of it and make it something that is lasting. Good source code is well readable by humans, not just by the computer, to which we send it to evaluate. And it should be as much self-explaining as possible. And you should be able to understand it a year later what you wrote a year earlier. Not always easy if you are not somewhat disciplined. Okay, so this gets us to the second guideline. Keep the R source well readable and maintainable. And here I kind of emphasize that well readable and maintainable are somewhat synonymous even. Well, at least one of them, the readability, is a condition for maintainability, for nice maintainability. Do indent lines. Use spaces around operators. Things like that. Use an editor that does this automatically for you, or get in the habit of doing it. Do not use long lines. There's a good reason why newspapers have columns that don't span wide lines. People now, they like to look at the computer screen like that and write their Word document in a wide format. I wouldn't really recommend that for a source code. Even I see many young people doing that. It's faster to read if you don't have very long lines. Faster to wrap around yourself, look at correct code and things like that. Then, do use comments copiously. About every 10 lines here I say, there are many ways to do that. Here I use these old recommendations that RCore itself uses. So if you look at the R sources, we have 1 and 2 and 3 hash for starting our comments that are sometimes used and supported by ESS. That was one of the reasons. Actually, it's a Lisp tradition, and as some of you know, Ross and Robert wrote R in a way originally that was something like Lisp with an S syntax. So even for historic tradition, it would be nice to use this key. Even better than just use comments, you can sometimes much more efficiently nowadays use Sweave or Knitr or R Markdown or other no web system, arg mode in Emacs. So systems which combine text, explanation, and R code in one document. Most of you know about that as well. And then there is this one-page, well-readable code and the assignment operator. I'm severely biased about this, but I believe that using a 2-character arrow instead of equal sign leads to far easier readable code. And there are arguments for that, and I'm not rehashing all of them. The equal sign, of course, is used in almost all other programmings as an assignment operator. But in R, the equal sign has 2 different meanings already. Namely, one of them is in function calls, notably list as one of the important functions which typically has many named arguments, and then function definitions, so the formal arguments of functions. The left arrow stands out visually, and then it can be nicely marked up by font color or other means. If you mark up all equal signs, as I think Knitr, for instance, does, and then others, then you really mix up the 3 different or 2 main meanings of the equal sign. And I think it's useful for teaching and also for reading code that assignment as something special stands out from the other uses of the equal character. And something that not many may know, there is a keyboard shortcut. It's not that you have to write more letters. And nowadays, both in RStudio and ESS, if you use the Alt and the minus together, then you get the arrow plus spaces around it. So I think in RStudio and in ESS, it uses 4 letters, space, less, minus, space. Give a nice assignment arrow with everything around. Okay, this was the page about the assignment operator. Well-maintainable, readable code. You want to often use naming conventions. Here, I don't mean about these style guides that typically are different from company to company or schools to school, but here I really mean that you should try to use naming conventions within the R base language, so to speak. There are many functions that have similar arguments, and why not use the exact same name? For instance, verbs is something, or you've seen different ones. Plot, not plotting, graphics. Do not impose rigid rules here, since, as I said, programming is an art, and with rigid rules you never produce art. And so all the rules that you do about coding, styles, naming conventions, if you're too rigid about it, the fun and the art is lost. And the second reason why you cannot impose rigid rules, the S language has a very long history. We heard it this morning, 38 years. And some function name and argument name decisions have been made, and we don't want to rename functions just to get the consistent naming scheme. So there is a history with historical misnomers of functions, and many of us agree that we want to live with history rather than get a system that, as it was designed by a computer itself. Modularity, clarity, refine and polish your code. This is from useR, being variables and Rippling, one of these books that many of the older generations still know about, using S and R for statistics or S programming. Refine and polish your code. Okay. Yeah, I'm losing here one part that I wanted to say. The next rule is about the third one, read the documentation. And of course, we can all laugh about it. People are saying, well, I cannot understand the documentation. Help improve it. If part is R is free software, it's open source software, it has been done by people like you by providing better source code, and the documentation in this sense is part of the sources, so why don't you submit patch proposals to better documentation if you don't understand it. But here I mean other stuff, like reading and reading again and reading a third time after knowing a little bit more. Read books about it. There are good books, many of them are sold outside here. Then there are the manuals that are produced by the R core team. The introduction to R being somewhat dated, writing R extensions being very important when you're mutating from a useR to a program R, which most of you probably are if you follow John Chambers' basic idea that you want to, or the book title, that you do programming for data analysis, or you turn ideas into software and you all mutate into programmers. Our package vignettes, of course, have become a very good source to read and carefully read instead of other stuff. The help pages and their examples. I cannot overemphasize the importance of good examples. Both if you are a package writer, write good examples, more than one. It's not about satisfying cran check requests or something like that. It's both. It's good to have examples that have to be run and rerun by the package checks, but it's also good examples to teach the users of your function typical usages of the functions. And then use help search. That's the built-in way to find stuff within R and install packages. And you can also learn about fuzzy matching and regular expressions if you haven't. The last thing, web search, also called Googling nowadays. You find, as you know, you find thousands of documents on every topic R. And I think these are used too much. Maybe not by you. Many of these documents you find, they are dated, they were correct at the time they were written, or they were good enough for government use, as they say, when they were written. They were not quite to the point, and then they get even less to the point once you find them 3 years later on the web. So we would like you to use the official docs, the help pages and the vignettes that the package authors and or the R core members have written for you. Okay, the third guideline or rule. We have been seeing that R should be something, R programming should also be comparable to an art, and to become an artist, which I never did in painting, you learn from the masters. So in painting, in arts, there is all these famous names, Picasso, Van Gogh, Gauguin, Manet, and many more. In R, there is John Chambers, Bill Venables, Bill Dunlap, Will Tierney, Brian Ripley, R core in general maybe, Dirk, Stuart Hadley is here, and many more that I cannot name here. And learning from the master is just studying what they've done, right? The young artist, the art student goes into the art museum and looks at the picture, or nowadays she has a copy on the computer and tries to copy it and study the technique. So here, the thing is really not to be underestimated. When I learned S many years ago, I studied the stuff that John Chambers and Rick Becker and others had written, Bill Venables, and I learned from their code. And I would recommend learning by examples is still one of the best ways to learn some of this. Use the Sourcebook. So those of you who know Star Wars, that the real citation is, of course, use the Sourcebook. If you haven't installed the Fortunes package, you should do it now or after the talk. Fortune 250 is exactly about this. Barry Robinson, a very funny British guy, and funny because he has always these funny comments on the public mailing lists. Somebody asks some detail, and often the answer is, well, if you really want to see the details, everything is open source, why don't you look at the source code? And this is particularly true when the source code is in pure R, otherwise it gets a little bit more work. But I still want to emphasize, this is a good way to learn many things, and I still think it's not done enough. I've had a large conversation the last 2 weeks with somebody, PhD student, who used one of my packages, and in the end I just told her, why don't you read the 15 lines of code that this function is all about, instead of asking me questions about the function. Okay. Now there's an Easter egg you can find if you read the source code for the question mark operator in R. And let's try if we can make the demo work. So anybody there, if you answer that in this way to the R console. And by the way, this is a relative current version of R, R311 beta. R311 should get out early next week. And really should install it. R10 has, in my views, two bad bugs that have been fixed long ago in the patched version, but anyway. Anyway, if you add that, then you're not getting, so maybe I'm lost now. Let's try that. Let's try that, so okay, it works. Now, R is contacting Delphi, and the oracle is unavailable. Yeah, I apologize for anything. This also works in RStudio or ESS. You need some incantations of at least 4 question marks, in my view. Anyway. And if you read the R-based sources, you will find this, and you'll wonder, well, okay, R-core has had some humor, and for it is Easter egg sources. To my view, it's the only one apart from funny comments that you can read in the source code. Okay. Read the source of R packages. And of course, as David Smith likes to say nowadays, R, for most users, is more about R packages outside of base R than about base R itself, with 5,600 something cron packages, not to count the bioconductor packages and those that are not available from cron, but for instance on GitHub or R4. And as I always like to emphasize for people who are not aware of it, the source of an R package, of an R function, is not the thing you see when you type the function name. It's nice to type the function name and see a rendered version of the original source code. But typically all the comments have been lost in the meantime, and often authors, package authors who follow my guidelines, namely writing well-readable code, have formatted their version of the R sources much more nicely than it is what you see when R has parsed and deparsed that original source. And there is an RFAQ, frequently asked questions about R, the FAQ 740, how do I access the source code for a function? And almost 8 years ago now, there has been an article by Uwe Ligges, one of the younger members of R-Core, about accessing the sources in the R news, and there's even the link up here, still working. So basically, it's what I say here, download the source package from CRAN or from GitHub. So that's the one that ends in .tar.gz, not anything else, because it's not the source package. If it doesn't end like that, unpack it, read it, experiment with it, and learn from it. You learn a lot, and I learn a lot still by reading other package authors' sources. Or browse the package source on Forge, GitHub, anyway. Nowadays there are many more possibilities, but do that and learn. The fifth rule, do not copy and paste. And this is actually a rule that could apply to all programming that I know of, not just to R programming. And of course, many of you, and I too, often work by taking something and modifying it to something new, something similar. And that's not bad, and that's often a good thing to do. But if you do this within your own code, you may get to something which is not well maintainable. Namely, you take a function that doesn't quite do what you want, but does something similar. You modify it, you make a copy of it, you modify that copy to do the thing you want to do as well. Now you have two versions of your original function. One does flavor A, the other one does flavor B, and they are somewhat different. But if you do that and keep doing that, and you find bugs in version A of your function, you will fix it there and forget that there is a function B, a version B of that function around. You don't fix it there, or you introduce a feature in one place and not in the other. You get a lot of inconsistency. And we still see this problem sometimes in base R, sometimes in well-known package sources. It happens to everybody, and it's a good principle to think of: do not copy-paste if you can. Write functions with arguments. I mean, we all write functions if we're package authors. But instead of modifying a function into a second function, modify a function by making it more general, by adding more arguments. And of course, the function will get longer. If you do well, then you can do methods with S3 and S4, and you have a new method for a new class. But try to do that. Try to extend and generalize existing functions. And if you have parts of the function that do almost the same, try to write small local helper functions. They can be nicely hidden in a namespace, so they don't have to be documented, they don't have to be visible to the user. The small functions, they can even be functions inside the body of your big function, so they can use the objects in your big function without a problem. But modularizing into many small functions instead of copy-paste makes everything less error-prone, easier to debug, easier to use, easier to extend, and long-term easier to maintain. Anyway, so one example is also a very simple, a very special example about not copy-pasting. On the bottom of the slide you see if A, then some complicated index to a matrix is an expression, and if A is not true, there is a different expression that is evaluated. And this looks silly like that, probably, but this is not uncommon seen in other people's sources. I know because I read other people's sources as I'm preaching to myself. If is something like a function in R, so rather do something like that. Mat is the result of an if. If A, it's the A expression, else it's the B expression. And so we don't copy and paste this complicated row and column indexing. Of course, you can assign the row and column expression first and do that, but you should get used to that actually f is a function in R. We'll get back to this, which has a value even if it has a funny syntax. And strictly speaking, very internally speaking, it's not just a function, it's a special thing. A little bit more about using functions. Everything you do in R is calling functions anyway. And we're getting to this morning. In R, everything that exists is, now we have the two rules of John Chambers. Those of you who are here, if you're awake, you should be able to answer the question. Everything that exists is an object. Everything that happens is a function. Thank you. Function call for a function. Anyway. There's a quiz, not a real hard one for the experienced ones among us, but it's kind of a nice quiz in the context of considering if to be a function itself. So when if is regarded as a function with three arguments, the last being optional with a default, what is the default? Okay? Well, if I only ask that, it's kind of a hard question, but I'm showing you the corresponding R code to kind of remember you. Oops. Now I've given it away. So. If CA is one way to use if clauses, if CA else B is the other way. So the if function has three arguments. The first two, namely C and A, are compulsory. The third one, B, is optional. Now what's the value of that function when the optional argument is not there? So if you have no else clause, what's the result of if else would be taken, right? So if the condition is wrong, well, you've seen the answer. If false, returns null, invisible. So many code pieces where some people write if CA else null, and this is not so uncommon, could be simplified by leaving away the else null part. But anyway, the thing is here, if you can treat everything in R as function, even the if you can treat as a function. Okay. We're getting to the second last rule, strive for clarity and simplicity. It's not a rule that I invented. Try that first, and second, and again, and try more and more. I see so much code, and we see code posted that doesn't do that. Probably none of that code is from you, but still, tell this to your colleagues. Think about naming of intermediate results with self-explainable variable names. Use short names plus comments as soon as these variable names are used more than 1 or 2 times, because they typically used in formula. It's easier to read if these variable names are short rather than if they have 12 letters and a state and a formula that extends, that takes these long variables, extends to 100 characters, even though if you use one letter variable names, it would only be 20 characters. So as soon as you get into formula, then you want to have something that looks a little bit like math, and then you rather take short names. Reynolds and Trinkley wrote also now almost 20 years ago, refine and polish your code, so we're getting back to that, in the same way you would polish your English prose. Of course, Brian Ripley, being from Oxford, always emphasizing good English, which I don't speak or write, but anyway. Refine and polish your code, so we know how to speak R, so we should be able to do this with R prose code. And we have a dictionary to the language, that's the reference material that we write, so we should be able to do that well, or it has been done before us. Optimization is sometimes the contrary of clarity and simplicity, and I'm getting to it in a moment. Test your code. This is not to be forgotten. Carefully write small testing examples for each function. Use modularity in testing. This is called unit testing. Applied computer science. The next step, put your code into an R package. There's the package skeleton function that helps you get started. There is now newer stuff from Adley and his dev tools and other tools. The nice thing of writing a package is you have automatical tests. Part of them are absolutely for free for you as an R code writer. Others you have to invest a little bit. For instance, you have to add examples to your help page, or you have to if you follow my guidelines. You should do specific testings in a test subdirectory, or nowadays also using, for instance, a test stat package. Typically, you want to compare numerical or known results with the ones that your functions compute, and make sure that these remain. Document your functions. That helps very much on getting good code. And I've done many, I'm still maintaining quite a few packages, and I'm careful about writing good documentation. That's actually why I don't use Roxygen much, just parentheses closed. If you document your functions, you think more about what it's all about, and often you improve the code when writing the help page for a function. That has happened to me many, many times, and still does. So the exercise of writing an R package helps you to improve the R code considerably often. Even if you don't even try to get it approved on trial. Okay, and then nowadays there's software tools for testing built in R. There is the tools package, there is the code tools package by Luke Tierney, which actually, part of which is used when packages are checked with the R command check. But you can use the code tools as well. It's a small package part of the base R, which, for instance, you can tell it to look at all your function and see if they access global variables or what objects they access, and you can use it to find if you're using non-local variables, which typically is bad practice. And then there's the unit testing, I already mentioned, or unit test data and so on. Only after extensive testing should you start about optimizing. That's at least the basic outset. I know that there are some situations where this is not true for 90% or 99% of our code. Optimizing should come long, long after testing, validating, and thinking about what you're doing, documenting, and so on. There's a Venables and Ripley's book on S programming. They cite an older book on programming, principles of program designs. Rule 1, don't do it. Don't do code optimization. Rule 2 for experts, don't do it yet. Not until you have a perfectly clear and unoptimized solution. So don't go to C or RCPP before you have a pure RC version that at least works fine for small cases, that you can check, that you can write test code already before going to the other thing. And don't do it yet until you have a perfectly clear and unoptimized solution to the right problem by an efficient method. Well, there's the other saying by another well-known programmer, Donald Knuth, who wrote Tech, which became LaTeX, and wrote the important book about algorithms in the 1980s. Premature optimization is the root of all evil. Premature, of course, you have to decide when it's, and often it's premature what is done. Doug Bates, another R-Core member with whom I collaborate a lot, has told himself and me that, yes, he falls into this trap again and again and again. If we want to make things faster and we are good R programmers, we kind of know how to do it, don't do it yet unless you have done all the other things. Okay, and again, clean up your code, test your code, think twice before you even start contemplating. And then if you go optimizing, and here I'm saying something I heard yesterday in one of the tutorials, do measure, not guess. And there is also a citation about our help question. Another R-Core member, Thomas Lumley, answered the question even now 13 years ago on our help. He said there are two fundamental principles of optimization. Don't do it unless you need it. Measure, don't guess. About speed. This is the topic now, so it's kind of rehashing, and then he answered about the tools that were available even 13 years ago. Our prof is still used. Unix time is a version of system time, garbage collection, and more. And in 2014, we have much more than that. We have the R benchmark package, the micro benchmark package. Yesterday I learned about the PBE-prof package, prof or profiling, and there are probably even more packages that help you profile your R code so that you really know which parts are fast and which parts are not, and you only optimize the parts that are slow and important. They're slow and used a lot. Slow parts that are used only once in your whole function call, in a function that you only call a few times, don't have to be optimized. They should be clear to read. Rather have clear code than optimized code that is a bit faster, most of the time. Anyway, so in sum, we have these 7 guidelines, and they are still relevant. I'm quickly getting the list of them. Work with source files, keep the source well organized, readable, maintainable, read documentation, program against the documentation as a specification, to learn from the masters, do not copy paste. And test, test, test. Okay, there are new guidelines I quickly wanted to add. Maintain the R code in packages. This is implicitly an extension of good testing, well testing your code. nowadays use source code management. That will also help you to organize things, to better test things compared with previous versions, or version, GitHub, or other such tools. And there's a new guideline I would want you to preach a little bit. Our script or our command batch of my source.r should always work. Of course, that's always is a little bit an exaggeration. I still see too many people, PhD students, my students, colleagues, professors, that organize their R code and only they know how to use it. They know first I have to do this, then I use that part of my R script, and then I do that. Or they load a saved data set, and only with that things work. So my strict rule is do not use .r data. Not really ever. Don't save your workspace. Rather, get them the discipline to do something different. Use save explicitly for expensive parts, and then consider attaching instead of loading these expensive parts. There's a nice, that's not much now, there's a nice difference between the two. If you load such a saved thing, or .r data, for instance, it overrides everything that you have in your workspace if it has the same name. If you attach an RDA file, so a binary R, a file full of binary R objects, they are put on the search path, but not into your global environment. Of course, you can use load with an extra argument to do something similar, but that's exactly what attach with an RDA file actually does. It loads it into a new environment that it attaches to the search path. And in organizing your kind of reproducible research code, it's very much linked to that part. I skipped over it, but I have written it here. The reason I want these to always work is it's about reproducible data analysis and research. This is a nice thing to organize such parts. Instead of .r data, which contains all stuff and overrides local variables, and, may get lost because it starts with dot. Do introduce a save file variable, then have the following snippet. If file exists, save file, attach save file, else do all the computation that lead to that stuff and save it here as the final part of this clause. So this, even if the ... extends quite a bit, this makes it transparent that if you have, this is a way of implicitly caching, right? So there's another way of caching our computations. This is very manual, but it's still not ugly, and it's still done very quickly and very transparent. Okay, I get into the last, or to the new part that I wanted to emphasize. Sir, when he introduced me, mentioned that I'm maybe because I'm a Swiss, maybe because I did my master's not in statistics but in numerical analysis, or I have been always interested in getting the R functions that compute mathematical stuff computed very accurately, as accurately as possible. And the most famous or the most frequently asked questions, or the most FAQ, is really the FAQ 7.31, as it's nowadays called, floating point numbers. Problems, why doesn't R think these numbers are equal? The example that's given here is if A is the square root of 2, and if you compare A squared with 2, of course it should be the same. The square root of 2 is 2, but of course it's not true in R. Oops. And if you look at the difference, there is a difference that is actually 2 times the computer epsilon, for those who know. And something like that is very, very usual and typical. There is this what every computer scientist should know about floating point arithmetic, and I could say what every good R programmer should know about floating point arithmetic. It's a bit much reading, so it's about 40 pages, but you can skim it and you'll learn a lot from it. It's quite well written and nice. By the way, in the end, the FAQ 731 ends with this, to quote from the Elements of Programming Style, Koenig and Ploger, also from Bell Labs, like John Chambers, the inventor of C and S. He wrote 10 times 0.1 is hardly ever 1.0, and that used to be true, but for some reason in IEEE arithmetic in R, this is nowadays, I think, true on all platforms. So it's lucky that it's working, because the reason why this is, the sentence in principle is okay with 0.1 is not representable exactly on the binary computer, and so it's not represented accurately in the double precision standard. Because it's not the power of not the multiple of a power of 2. Okay, and so the fact extended is one example that happened actually at the first R-Core meeting is the log. So John Chambers and I were talking about it, and I introduced it into our density and probability functions in R all have a log argument. Well, why is this important? It's more important than many people seem to know. One important application is likelihoods, and if you compute likelihoods under independence assumption, this means a product of many probabilities or density values. And if you do some things like that, also in probabilistic networks, in MC, you have probabilities that are a product of many other probabilities. In MC, these are typically conditional probabilities. They quickly underflow to 0. And then you get 0 probability for something which, and 0 probability is really a problem. Then you believe that atomic nuclear power plants can never explode and things like that. So what you have to do instead, work in log space. And this is still not happening enough, and as people find bugs in their software because they don't do it from the beginning. If you have to work with many probabilities, very often you want to store the logs. And so log P is the sum of the logs, but the logs are not computing by taking logs of probabilities, because even these probabilities could already have underflow. So that's why the R function computes the log probability directly. And so the log probability can be minus 10,000, whereas e to the minus 10,000 has long underflown to 0. Okay, that's one important thing. Now I have to wake up. Why R needs even more basic functions. For R100, which was 29th of February 2000, we've introduced the log1p function. Who does know this function? Well, not too many. And 5 or releases later, the xm1. So why is log1 plus x not good enough? So this is answering what the log1p function does. And I don't have time, as I've realized, to get into the real details, but of course, if x is a real small number, so think of a probability again, then 1 plus x only sees a few digits. For instance, if x is 10 to the minus 14. Here is a little bit R code demonstrating. I take one of these small numbers, and u is 1 plus this small number, and if I show u minus 1, and the original u minus 1 only has 3 digits of the original. This is 44444, right? That's the e for e. And if you do, of course, you lose all these digits. You only have about 16 digits accuracy. And now the same problem really happens when you take the log of these things. And here is a plot of the relative error of log 1 plus x. So log 1p is log 1 plus x, but accurately. And you see, if you're here at 0.1, 10 to the power of minus 1, then you have almost 16 digits accuracy. That's the relative error, and 10 to the power something exactly gives you the number of correct digits in the exponent. But as soon as you go to 10 minus 10, you only have about 8 digits accuracy. If you go to low, you end up having no accuracy at all. And so the log1p function solves this problem easily by using the famous expansion and using a fast version of that even in the C implementation. And in the meantime, log1p is actually part of the standard for C and C++, so they are in library functions in newer C and C++ standards. And the same is with expand1, which is kind of the inverse function of this. 1 minus exponent of something is also leading to cancellation. When the argument of the x is close to 0, then x to that argument is close to 1, and 1 minus that thing cancels. And this can also be detrimental. Okay, the next version of R, which is the next major version, 3.2.1.0, will have these functions. They are actually also partly in new C++ standards. If you compute cos of pi half, you've learned in high school that this should be 0. This is the cosine at 90 degrees. But it's not in R, and it's not our fault that it's not, because pi divided by 2 is just a number, and the cos function tries to evaluate it. And it gets very close to 0, but often you don't like that. And so cos pi is corrected. And then there's a new function, and I have to skip almost all of it, that may even enter. It's already part in our MATLAB C code, so some of the distribution functions, the density, probability, and quantile functions, use even something where log1p and xm1 are not enough. And here is an example of the compute logics, logistic regression on a logarithmic scale. You get to something like log of 1 minus x of minus x, so this gets into real math up here. And if the probability is really small, something like 10 to the minus 1000, and as I said, this can happen if you want to work accurately with probabilities, you want to move to the log space. In the log space, you compute log of 1 minus x, and then you have both log 1p and x and 1, and both don't quite work, or at least not work simultaneously. And if you use the usual code, you get early underflow, and it's so you jump from 10 minus 16 to 0 directly, which is a big jump in log space. You jump from minus 16 to minus infinity instead of going there directly. And you can work around it by using one of the interface packages that I'm also in that uses accurate numbers. MPFR is a C library that allows arbitrary accurate computation. And you can do that at least for smaller versions. And so here I show a version that uses 120-bit accuracy instead of the usual 53-bit accuracy. And there you don't underflow so quickly. But of course, the real solution to this problem, the logic on the log scale, is doing something else, which I'm not showing. I have to wrap up. I have a list of specific hints that I sometimes want to show, but they are not so important. They will be in the outlines. Since this is mentioned all the time, I mention it as well. Instead of xint, use xint, drop equal false in your functions. Very often, this is what you want, because you want to have a matrix. If you had a matrix originally, you want to get something that remains a matrix. And I think many people agree, at least, I hope John agrees, who is here, that this is, as far as I know, this is basically the only design flaw in the S language, that one hasn't thought long enough about that. Hearing his talk this morning, he may not even agree on that, because S was not designed as a programming language. It was designed to have an interface to good algorithms and be convenient. But anyway, this is one problem. The other thing, the hint is NA. Almost never nowadays you use 1 colon n unless you really know that n is positive. Things like that. I'm skipping. I want to allow for some questions, and these specific things here are not so important. So my last slide is, what is your style of R programming? Perform the art, enjoy, and be productive at the same time. Thank you very much. A question?
You say optimizing should be done at the very last only. Are you only talking about replacing algorithm with C or Fortran or whatever? Or does it also include replacing the for loop with LFI or something?
Okay, I repeat the question. I said optimizing should come at the last part of developing your code, after testing, after documenting, and so on. Do I only mean replacing R by compiled code, such as C, C++? No. If you're a good programmer, many in here are, you may use lapply from the start because you know about it and because it's easy for you to use lapply. Yes, then do that. But if it's your student or your beginning R colleague, why shouldn't she use or he use this for loop and test it and then somebody tells him, yeah, you can do this faster. But get it right first. And see, a for loop of something that is not executed many times is very readable. A for loop is actually often more readable than an lapply. Sometimes it's not. Sometimes it's very natural to use lapply. Yes, I still would say that's true. Go for clear code, well-readable code first, and think about optimization later. And actually sometimes keep the original well-readable code as an example of what does happen and for documentation purposes. So in some of my packages, I have an R version of a function which is slow, but everybody can look at, and there's a C version that, a version that calls into C, which is fast but is not transparent to the user. Other questions? The gentleman back.
Martin, you make it sound like contributing changes to the R documentation is easy, but in my experience, it's rather difficult. What can you suggest as far as making it easier for me and for you?
Question was that I suggested that it was easy to make suggestions to improve the R documentation, and the gentleman said, I cannot recognize you, I probably should, that it's not so easy because some people in R code are not so nice to you when you do that. Sometimes things like that, right? Well, I have personally added suggestions to the documentation several times. Dr. Murdoch has, others have too. Of course, it's always a bit interpersonal issue. How do you do that? If you see, for many of us, R is our baby, and you know, the worst thing you can do to a mother of a child is to tell her something bad about her child. I mean, this is really the worst thing you can do. And so, try to do it in a nice way. That helps. And yeah, I forgot there were other. You were first. And then. So
these are all great suggestions, and we should all follow them. At least I follow them all. But do we have any empirical evidence that following these actually improves anything? Have we run tests?
Okay, very good question from a scientist like and many statisticians should be. Do we have empirical evidence? Do we have data that suggests that following these rules helps in the long term? Actually, I don't know of any collection, a systematic collection of empirical data, but maybe someone else has. I have my own experience, but we all know experience can really be wrong. Computer scientists usually try to collect such data, but then we've seen actually with R that they have a biased way of sampling in some ways. But I guess if we find somebody trying to collect data and then analyzing, I'm pretty convinced that it would be strikingly clear that it's worth it.
I am too, but I just didn't know if I just had
Thanks. So, here?
You suggested that to really understand an R function, you should read the source code kind of as priority over the documentation. But I always thought the documentation was the contract that we should be looking at. And the source code might change.
Yeah, actually, I should repeat what you say. And I'm not agreeing that I said that. So he was saying, I was suggesting that reading the source code of a function was more useful or more definitive than reading the documentation. I tried not to say that. If I have accidentally, I didn't want to. I said that you learn a lot by reading the source code. And that's, I still think is true. You should read the help page first, and then you can read the source code to see, well, how did she do it? How did she fulfill the contract she's promising on the help page? So that's not quite the same thing. Yes, you were?
I saw in your slides that you mentioned using attach. And I've seen lots of other references that says that should be banned.
Yes, thank you for the question. I mentioned using attach. Actually, I wrote to one of the lists a while ago. There's one good use of attach, and that's the one I've shown. Do not attach data frames. That's correct. And that's what people mean when they say you should ban attach. Those people who say you should ban it, they don't know or forget actually that you can attach data objects. And for that such safe data, of course, you don't need attach. You can attach to an environment, but then you definitely need 2 or 3 OR statements instead of just this one. No, actually, people who say you should ban attach, they should mean you should ban attaching data frames and then work with the code names of the data frame as variable. I didn't mention that because I skipped. You should use with data frame and then do that instead of attaching a data frame, but attaching a binary or object file is much better than loading it, and people do load them all the time.
Sorry, but
yeah, I think we have to close it. You can address me. Thank you very much for your attention.